In this very short tutorial, I'm going to explain how sample size impact statistical power. So power or statistical power, namely is 1 minus beta. So it means that when the non-hypothesis is false, namely the H0 is false, and we reject the non-hypothesis, namely 1 minus beta. So the 1 minus beta is the power or statistical power. So it's the probability that the non-hypothesis falls and we correctly reject the non-hypothesis. Another key concept here is the sample size. So sample size is the number of observation or individual measure or included in a study. So for instance, you are going to run a survey and you need to recruit a group of participants to answer your survey. And the number of these participants is the sample size. Another concept that is relevant to the discussion here, but it's not the focus in this tutorial, but let me just put it here. It's called effect size. So there's small, medium, large effect size, and I have other tutorials about effect size. I'm going to put the link down below. So here I just mention it here, and if you have questions, you can refer to those tutorials. So there are two remarks I would like to make here. So for a given effect size, as sample size increase, the power also increase. So the basic idea is that the sample size get large, then we have more power. Another one is that for a given effect size, as sample size increase, the observed p-value will decrease, meaning that we are more likely to reject the non-hypothesis. Okay, let me just use an example to explain these two remarks more. Let me go to Shift to R Studio. So this is the R model file, which is the PDL just saw. So I generated the PDL file based on this R model file. So here is that we use the library PWR, and then is this function. So we say that the sample size is 100 and the effect size is 0.3. And the alpha level is 0.05, and we're going to see the power. So see how it looks like. And this is two sample t-test. And we're going to print out the result. We can also plot out the result. So let's run it. And so this is the result. It's so that the power is 0.56. And here, okay, let me put it. So here is actually, you say as a result, you can plot it actually. So basic idea is that this is the sample size we predetermine 100, so 100. So basically this figure basically is to tell you that what's the power. So as we know that the number is 0.56, namely 56%. Yes, so that's the power. As you can see that if we increase the sample size, for instance, go to 200 or 120, then the power is larger. Yes, so let's see what's the case. We can change the number, just change to 120 or even maybe 200. Let's just 120. So if we change to 120, then the power is 0.63, so namely 63%. Yes, let's plot it again. And so as you can see that now basically the figure is the same. It's just this dashed line moved from 100 to 120. So now we specify the sample size to be 120. Then we can see that the power is 63. Yes, so this is 63. So basically this figure, the x-axis is the sample size, the y is the power, and you saw that as you can see that as the sample size increase, the power also increase. Remark 2 is about the p-value. So basic idea is that as the sample size increase, the observed p-value will decrease. And as we know that when p-value is smaller, then that means that we're more likely to reject the non-hypothesis. So let me go back to the R Studio, and then I'm going to use some examples to demonstrate this remark. So basic idea is that we're going to say that the effect size is 0.4. That's predetermined, so we're not going to change the effect size. And then we are going to two sample t-tests here. So we're going to put a total sample as 200. So each group has 100. We have two groups. And so the sample size 200, so let's just run it to see the p-value. As you can see that the p-value here is 0.13, yes, so which is greater than 0.05, so we actually will fail to reject a null hypothesis. And we can actually increase the sample size here into 240, yes, that's just like each group now is, instead of 100, we put it as 120. And let's run it. So the p-value now is 0.003, so which is smaller than 0.5, so we're going to reject the null hypothesis. As you can see that for the given effect size, if we can increase the sample size, actually we can observe the p-value smaller, which means that we are more likely to reject the null hypothesis. So I think that's it. So I kind of show you how sample size impact the statistical power. And if you have any questions, feel free to comment down below, and I'll do my best to answer the questions you might have. Okay, thank you for watching.